Welcome, everybody. Just working out the technical. Thank you, everybody, for joining us for Busting Solar Foundation Myths for Colder Climates. Today, I've got 4 guests with me to talk on this topic. Myself, Arash Yazdani, the Director of Engineering with PRI Engineering. Vishal Lala, the Managing Partner for Polar Racking. Greg Rossetti, the Head of Land Acquisition at OYA Solar. And Dan Carrocci, the President at Determination Drilling. Today, we're going to go through the design of foundation elements for racking systems in cold climates, common foundation solutions for cold climate foundations, economics of different foundation solutions, and then we're going to finally end with a Q&A period. Before getting started, we will let each speaker introduce themselves and their respective company. Starting with PRI Engineering, we're a team of 15. We have 100+ years of combined experience in engineering and consulting and construction management, which has allowed us to provide full engineering solutions. Our specialization and our niche is design of foundations for solar mounting structures, where we've completed over 200 projects in Western Canada, Southeastern Canada, Southeastern Ontario, East Coast Canada, Northeastern United States, and the sunny Caribbean. As well as all those services, we've also got an in-house concrete and soils lab in our Lindsay office, and we're going to be expanding into other regions very soon, so stay tuned for some news on that. I'll hand it over to Dan from Determination Drilling.
Hi, everybody.
My name is Dan Carrocci. I'm the president of Determination Drilling. I've been running the business for 20+ years. We started out as a geotechnical environmental drilling contractor, and then during the feed-in tariff program in Ontario, we started expanding into renewable energy. Now that's all that we do is build solar farms. We've completed projects in every province and territory across Canada. Literally every province and territory, so that's a really big milestone. I don't believe there's any drilling contractor in Canada that's done that, so pretty proud of that. And yeah, we complete every type of foundation solution, which really makes us different from every other drilling piling contractor out there. We perform driven piles, helical piles, ground screws, bedrock micropiles. We have an array of remediation techniques that we can deploy to make sure that your site goes properly. We keep safety, quality, and production in mind with every single project, every single hole that goes in. And yeah, of course, Determination Drilling. Determination is in the name, so that's us.
Thanks for that, Dan. Moving on to Vishal with Polar Racking next.
Yeah, Vishal Lala, managing director and co-founder of Polar Racking. We founded the company in 2009. It's our 13th year in business. We focus on fixed ground mount, single axis tracker, and carports. And we've worked on projects all over Canada, the US, and the Caribbean. Full in-house team, geotechnical, structural, mechanical engineers. And in late 2021, we acquired Axis Solar, which was a division of Magna, and we took on their single axis tracker line, as well as their fixed ground mount line, and the team's combined experience is well over 3 gigawatts supplied right now. So
Thanks to that, Vishal. And last but not least, our friend with OYA Solar, Greg Rossetti.
Hey, everybody. OYA Solar, born out of greenfield development and have matured into an IPP with construction ownership of assets. I'm not sure what the total count is, but on the pipeline we've got, it's over 6 gig. And originally with a focus on community solar, born out of, again, Minnesota and then into New York and beyond. And now we operate throughout North America and Canada as well. I'll leave it at that.
Awesome. Thanks a lot for that, Greg, and the rest. So before jumping into our roundtable, just wanted to give a brief introduction on, the philosophy of the design of foundations for solar mounting structures. At the en route of the process, it all starts with, you've got to check your regional conditions, which involves getting design parameters from the racking supplier and also regional considerations, particularly in a northern climate, which is the focus of this webinar as it relates to frost penetration and frost uplift. When it comes to resisting these design loads, there's a multitude of foundation types, and there's a lot of different considerations that need to go into that. There's obviously the engineering piece. Constructability, though, is extremely important. If a foundation can't be adequately constructed, it's not the best foundation. It's got to meet the financial requirements. If it pushes a project over budget, it kind of defeats the purpose of the project. So that's got to be considered. And of course, in this case, it's got to be able to adapt with the racking system. So as you look around the world, driven piles has always been the preferred foundation type for these types of systems. They're cost effective. They're the simplest to install. You can utilize a multitude of cross sections. There is some benefits over some cross sections over others, and we'll dive into that a little bit more a little later. Typically for sites with at least 10 feet or 3 meters of overburden material, so that means 10 feet or 3 meters of soil overlying bedrock. Ideally, there's minimally no obstructions. There is, however, some techniques and types of foundations that can be utilized to combat those type of things. And the foundation itself typically develops its strength from steel to soil. Develops its strength from the steel to the soil skin friction. So you're basically getting resistance from friction between the ground and the pile itself. Maybe before we go on to the next foundation type, maybe we can just go around the room. If there's any comments or anything anybody would like to add to that.
I guess the one comment that I can make is that, from a cost perspective, this generally tends to be the most cost-effective solution of all, if you can get away with using a driven pile. The other thing is it's also fairly easy to source, because you're looking at a straight round post or I-beam that you're putting in the ground with limited secondary processes. So lead time wise, it also tends to be a favorable solution as well. So the one thing that I would comment on this actually, and pose back to you, Arash, is and maybe you, Dan, is we've had a lot of talk about driven piles, and I don't know if we're saving this for later or not, but since you opened it up, the round post versus the I-beam debate is something that we've all had quite a bit, and I don't know if you want to get into that now or later, or
you may as well jump right into it.
Yeah, we'll get into it. I think maybe before we get into it, let's clarify that our job is to go in and test a project. When Greg shows up to a site for the land development, he sees green grass and a flat site. He says, this looks great for solar, but we're trying to figure out what's under the ground and match the foundation type to the geology. So one foundation is not necessarily superior to all. There's no silver bullet solution. However, I do really enjoy driven piles because you can get really nice laser beam straight rows. They're quick and easy to lay out. The trucking itself, you have less transport costs because you're able to pack the piles onto the trucks a lot tighter. And just the quality of the install. Now, when we're talking about round pipe versus I-beam or H-pile, I'm a big fan of the round pipe, just because in order to lay out, it's a lot easier. You can roll it off the skids of your forks of your skid steer. The install, there's no extra access. With an I-beam, you have to line up your flanges. They have to be laser beam straight across. But a round pipe, if you hit a rock and it twists and skews, it's okay because it's round. You don't have to have it that perfect flat string line across. So there are a lot of benefits to round pipe. After the fact, if you install the pile and it flies down faster than your drive time parameters, you can install a frost sleeve afterwards to reduce the frost uplift forces, With an I-beam, you don't have that luxury, and you actually have to pre-plan it. Like you can wrap a frost sleeve around an I-beam. You have to pre-drill the hole, pre-wrap it, install the pile. It's a big pain in the neck. So I find a round pipe is just a very user-friendly foundation solution. They're readily available, and they go in really nice with the right geology. That's my take on it from the ground, from the field.
Well, and thanks for that, Dan. I mean, that's the key. So, you know, that was one of the key things that should have definitely introduced, is that, you know, ultimately, there's a lot of racking suppliers out there. Not all of them can accommodate every type of foundation. There's unfortunately a lot of racking suppliers that, you know, say, you know, we're the driven pile guys, or we're the ground screw guys, or we're the, you know, they only have, they're one trick pony. And with that, you know, comes some constraints from a foundation standpoint. If you can't match the subsurface conditions with your racking system, it may lead to some constructability challenges, which, Dan,
yeah, it's like, hey, we have to make I-beams work on the site because that's all we can mount to, or we have to make a helical pile work, but there's like a layer of sandstone or something. Right?
Exactly. So it's not always, you know, conducive to the ground conditions, and that's where, you know, cost escalations happen on the construction side. There was a lot of benefits that Dan mentioned about, you know, the layout and the constructability, and then just the ease of working with a round post versus a W section. But that's where, you know, maybe I'll just flip it to you for a second, Greg, and
Sure.
and the, you know, the cost implications, you know, really come into play. You know, if you're dealing with, you know, a round post versus W section versus, you know, which we'll talk about in a second, a helical pile.
Yeah.
And, you know, what do you see from getting these projects off the ground from a cost standpoint?
Well, I look at it as a bit of a funnel. So you've got some of your very high cost items, and then you work your way through the funnel. And unfortunately, in this day and age, these projects are so price sensitive that you really do need to worry about the bottom of the funnel. Almost, obviously not as much as the top of the funnel, but you need to worry about the bottom of the funnel, or the projects tend not to pencil. And what again, just to try to paint the picture a little bit more, you know, panel prices, obvious, supply chain issues with racking and everything that we've been dealing with over the last handful of years, policy issues, go through the list. I'll put those as obvious sort of top of the funnel type concerns that we have when we're looking at project economics. But at the end of the day as well, you start getting into the minutiae, and without getting into the minutiae, these things, you just don't make them work. So let's get a little bit more technical. Interconnection, obviously, throughout North America is becoming a massive challenge to find capacity available at a reasonable price, and just understanding through the life cycle of a project at what point you arrive at the conclusion that, hey, I do have a site that has reasonable capacity. That could be a whole other sort of discussion just around capacity and the challenges that lie there. But ultimately, you know, to Dan's comment about when, you know, we pull up from a land acquisition standpoint, we see a nice flat site. Yeah, that's very true. That's what we're looking for, obviously. But there are all those concerns throughout the funnel, below the ground, finance, you name it, everything that I've just been sort of describing at a high level. And ultimately, you have to find solutions for those smallest of price drivers. And as you work through the funnel, subsequent challenges become more and more critical to the success of a project. When we arrive at geotech starts at a couple of different layers. It was discussed at a couple of different layers, in my opinion. It's like a bit of a layer cake, and geotech finds its way in at a few points throughout the life cycle of a project. First, obviously, you get to a site. If it's you're walking on bedrock, well, obviously, you know that you've got a challenge. But shy of that, you have a farm field that's you know, a hay field or it's being row cropped, and you don't know if you've got 18 inches of topsoil and then underlying clay for the next 20 feet or 50 feet.
Minefield.
Yeah, you have rough knowledge of the geology in the area, and frankly, I have that knowledge because of conversations over the years with people like you, Arash. So having a general sort of a view on where your geotech's going to land is important, but then you have to get into the finer points, right? And ultimately, whether it's a driven pile or the piles that I'm sure you're going to get to further in this presentation, it's finding those economies where a 5 megawatt site or a 50 or something larger, you need to be able to look at these sites and say, it's driven pile for this section, it's possibly helicals here, it's possibly something else in this area. And having a team, sort of like the team that's sitting at this table, where you can all have, there's a level of experience, so you don't need to reinvent the wheel in discussions and re-educate people from day one, so you can accelerate your way to a solution that much faster. And you can come up with a plan where, okay, it's driven pile here, and like I say, helicals here, maybe that combination.
Zones and
right, and ultimately you need a flexible racking system. You need a contractor, a drilling contractor, who understands that that's the nature of these types of projects in order to make them successful for a developer. And if the developer is not successful, and the economics don't pencil, and you can't arrive at something that looks in a spreadsheet like you want to move forward and make the investments, the sizable investments to get one of these things operational, none of us get to play at the end of the day. So,
right, yeah. Well, one other point, if you don't mind interjecting, it's just to pick up on your point about having, driven in section A and then helical in section B. Like, we have worked on a lot of projects. Arash and I specifically, where it was, designed by others, where, it should have been driven in section A and helical in B, and then they just put helicals throughout the site because, that's what was easy for them to design.
Yeah, a rubber stamp.
Exactly.
And I ran into that too, Vishal. It's tough.
Exactly.
As a construction contractor, we're pulling our hair out. It just makes morale on the site. Everyone hates their lives and hates the job. If the foundation works with the geology, it's a happy, sunny day site, right? Like, if the morale on site, you can just feel it, you can sense it when you're out there. So proper engineering, it all starts right from the beginning, the preliminary site testing, the desktop study, geotechnical investigation, the pile load testing, and then the procurement. So it's in that order. That's exactly what should happen to evaluate the site and evaluate your options.
So some of the things that we've done, Arash and I specifically on some of these sites, is we know that there's a driven pile in section A and a helical in B. So we'll just design the rack to accommodate a round post. We'll put a round post driven in section B. We'll put a helical in A, so that the above ground connection doesn't change. And then below ground, like, we're putting in the right solution that makes the most sense for the site. Usually ends up being the most cost effective and easy to put in the ground. And that's like one of the tricks in the toolbox, and I'm sure we'll talk about a few more here, but I know that, like, in those instances, that's something, we've generally done. And then, we have done other sites where, we've done, ground screw in a section and a drum pile in a section, or whatever makes the most sense. And, like, one of the advantages we have with Polar in our design is, like, we do have a solution for ground screws, for driven piles, for helical piles, for ballasted solutions. So we're able to adapt along with what the ground is telling us to put, rather than us telling, hey, put this in the ground because this is what we sell. So
you're both making me think that, against my little analogy about the funnel and making the comment that some of these things about the piles become the smaller things. It's those smaller things, though, as you get further along in your development cycle and through and into construction, that if you get some of those, what may seem to be small things wrong, they can turn into some really, really big problems very, very quickly when you're in the field. Because there's no easier way to throw the wrench right in the proverbial spokes of a construction schedule than to get your foundations wrong. Because you have different lengths, different styles, getting those manufactured. You don't just go to Home Depot and pick them up. I want the 3.5 inch, screw versus the 4-inch screw. You don't have that, especially when you have challenging supply chains like we have now that just amplify, compound, pick whatever word you want, then make it a nightmare if you don't get it right early on. You have to get it right. You have to be as smart as you possibly can be going into it. And then you can deal with the smaller challenges that inevitably arrive, but at least those don't cripple the schedule and then potentially cripple the project.
What we've seen a lot is people, they go for the cheaper option up front in the spreadsheet and then pay double to fix it afterwards,
Lucky
right?
if it's only double.
And yeah, and it's usually much more though. Like we're working on a site recently where, we definitely proposed round posts because we knew that there's going to be a lot of areas where you're going to have to sleeve it. And that's, for sure the right option. But like, if you go with the W section in that exact site, the sleeving becomes 5 times more, 10 times more, right? But people they get caught with the shiny number up front just to pay on the background. And that, that's unfortunate. We see that happening way too much in our industry, right?
And you're starting to sort of pull at a thread there that, maybe the cheaper solution will work. So there's a reason it's shiny. But if it's got a 20% chance of working, you really got to think, do I want to go down that? So how much risk is there in that? How likely am I to succeed with that, with the lower cost solution versus what's it going to cost me to pivot and switch gears down? So if you have an intelligent plan, then you can take advantage of those cost savings. And that is my point. What you're driving at, Vishal, that I guess that's the point I'm getting at, is that if you have the right team, you can explore the minutia of a project, the minutia of your construction schedule, procurement, all the rest of it to find those savings. But if you don't have the right team, and it's across the board from geotech to major equipment supplier, your racking supplier, your foundation supplier, often part of that racking solution, and then your contractor that's on site, that's actually got to do the work, show up Monday morning and actually put the piles in the ground and put them in the ground at pace. There's a schedule, and you got to put X number of hundreds of piles in the ground a day, or everything gets thrown off. That's, like I say, you got to get it right, and it can be gotten right if you spend the time to figure it out.
No, that's like, to synthesize, I think like the message coming from the group right now is you need a team. If you have 1 out of 4 people at that table saying this is the way and everybody else is saying something else, chances are it's not going to work. And, you need the developers buy-in, you need the racking companies, to be able to accommodate the different foundation types. You need the engineer to be willing to look at designing different foundation types. And then you need a contractor that can accommodate installing different foundation types. You can't have that one-trick pony. And, in fact, too often or not, we've seen it, and both Vishal, all 3 of you have brought it up, where you have a designer that tries to design a site with one foundation type. The likelihood of you taking a 40, 50 acre site and having homogeneous subsurface conditions is extremely unlikely. Whether it's 5%, 10%, 20%, 50%, it doesn't matter. Regardless of what that percentage of difference is, if that hasn't been accounted for in the design, you're going to have 5%, 10%, or 50% of the site where those very large construction costs that both Vishal and Dan alluded to, throwing Greg's spreadsheet out the window, and all of a sudden, the financing of the project is at question because, what was originally financed is not the reality. So, watch out for those spreadsheets. So we will,
and it goes without saying that, as we rattle through these pile types, and you've got helical up now versus a driven, you got to know that when you show up at site, whether you need a hammer or a screwdriver, they're 2 very different tools. And unfortunately, the types of hammers and the types of screwdriver equivalents that we use to construct these solar projects are not the kind of things that, again, you can go pick up at Lowe's or Home Depot. They're specialized equipment that require a specialized operator on top of everything else. So just because you can jump in one of those excavators and dig a trench doesn't mean you can jump in one of them and drive that pile in the ground straight, plumb, understand your torques, understand everything that field to put that pile in the ground. That's a whole nother, that's a whole nother piece of the equation that that sits with your contractor, obviously, but all of that dovetails with everything we've been talking about. Again, back to the team.
All that takes time to develop that team and the talents. Like, we've been building solar farms for 15 years. It took a while to get where we are for people to truly appreciate the quality control that goes into it.
Yeah.
So as we're installing these piles, whether it's helical or driven or bedrock micro piles, like, we need to record the subsurface characteristics and relay that back to the engineers so that they can look at that and say, okay, this is as per design. You don't submit the quality control correctly, that pile never happened. So yeah, like with driven piles, we're recording time. We're measuring every foot on the pile and literally there with a stopwatch recording the time as to determine penetration rates. Where helical piles, we're recording torque on a screen. So every pile will enter a pile ID number and a time. We'll start installing that pile, and as soon as that pile is done, we hit stop, and all that gets relayed to the client afterwards. So there's a significant amount of quality control that can go into these projects, and not sure that people truly appreciate what it is. Spent so countless nights entering data into a spreadsheet. Now we've actually taken drilling into the 21st century and we've digitized everything. So all our operators have iPads and they enter it all into their tablets. That way the client gets the information in real time, the engineers get the information in real time, and they can assess that and evaluate the install criteria right away and catch those, these piles may need remediation before they get racked. Often the racking crews are right on our tails. So yeah, by digitizing everything, it works really well. I find it's definitely the way to go. But here we have helical piles. So they can range anywhere from 14-inch to 36-inch helical. We've seen up in Huntsville some really big ones. Obviously, the bigger the helix, the harder it is to steer in the ground. Helical piles, just by nature, are these big clumsy things. They kind of warble into the ground. It really does take a lot of operator finesse to get them exactly where they need to be. Or however, they do have their place in softer soils. Like, yes, you absolutely need that helix to from keeping the foundation from settling, but also to resist the frost uplift. By having that helix, it's just a big dinner plate that's gonna keep that pile where it needs to be. We run anywhere from 20,000 foot-pound heads to 90,000 foot-pound heads. So as you can see, like, we basically turn our excavators into rotary heads into drills, and we're able to spin these piles down in the ground. You have a ground technician at the bottom there that's guiding the operator. We set offset pins. That's how we ensure accuracy. So a lot of these sites, we have to get that 20-foot long helical pile within a half an inch spatial distance for north, south, east, west, which can be very difficult in the best of times. But our operators are so skilled, they can get them looking really good. So yeah, that's now the bottom right picture there, you can see the helixes on the truck. That's what I was saying before, is a helix takes up a lot of airspace on a truck, where a driven pile, that airspace is gone. So you can pack a lot more helicals onto a vehicle, reducing your trucking costs. So yeah.
We're working on Dan's honorary PN. He explains it pretty good. I think we've had a number of geotechnical talks over the years, so I'm definitely happy that's rubbed off. Just a couple of things to add. Typically we're using this in situations, seeing as driven pile is the preferred foundation type. Once again, a lot of that is related to cost, but of course we've got to meet the engineering requirements. We've got to, in these northern climates, particularly got to make sure that we can resist frost uplift. In these cases, like Dan mentioned, we got the dinner plate on the helical pile. As long as you're able to adequately get the dinner plate into the ground without encountering boulders, cobbles. The other thing is you cannot penetrate a helical pile into bedrock, which is one major downfall of them, regardless of how soft the bedrock is. It's just not feasible. You will not penetrate that layer deep enough. So in order to, when you aren't able to develop the adequate uplift resistance, this is usually option number 2. But, as there was the transportation costs that Dan spoke to, and also some of the manufacturing costs that Vishal spoke to. That's a challenge. Essentially a round driven post is a helical pile without the helical blade welded onto it. From a material standpoint, there's not a lot of additional material, but that welding cost, that's done by humans, and unfortunately or fortunately, that's an added cost to the foundation. And you could look at a helical pile being anywhere from double to one and a half to double the cost of a driven pile from a supply standpoint. And I'd be curious, Dan, from an installation standpoint, is it kind of, readily the same production rates, roughly the same kind of equipment for support?
Quite a bit slower, and definitely different skill set of equipment. So we would run our Kite HRE 6000 pile drivers for installing a driven pile. We did start making our own drill towers that mount onto excavators. Those are pretty innovative pieces of equipment, and we're able to ramp up our production line on those. So that's a pretty neat thing. We've been using them on a lot of testing projects and even production sites. So yeah, the helical pile, good option. Our operators they'll be lucky to get 100 a day. They're pushing. 100 a day is really good if you can do that. I want to estimate about 50 to 75 per day if you're lucky. Driven piles, you're 75 to 100. So I push it a little bit more, like an extra 20, 25 piles a day. The ultimate for, as you mentioned, you can't get into sandstone or weathered bedrock with a helical pile. With a driven pile, I actually welcome that. If you can find a sandstone or a weathered rock layer within 7-8 feet area, you typically penetrate that with a driven pile 2 to 3 feet, and that locks your pile in better than concrete. There is no popping that thing out. So with a driven pile, you actually kind of want weathered rock. Where a helical, you're just looking for soft soil, no boulders, no cobbles. If you do start getting into the boulder cobble material, there is remediation for that. You have to spin it out, dig, hoe pack, resurvey, reinstall, which can be pretty costly and time consuming again.
Yeah, and then just a couple other benefits of helicals or places where they're used is, because of the round post, and we've spoken this at large, with the round post, you can mitigate frost with a frost sleeve, which is essentially a sewer pipe. When you got the driven round post, you can do the same. With the driven W section, not so much. there is a product out there called Yellow Jacket, but it's very, very cumbersome to install. It involves requiring it to do some pre-drilling so that you could fit the pile with the Yellow Jacket. And one of the challenges there, if you're using it as a remediation method, do you preemptively pre-drill every single hole so that you can accommodate a remediation method, and then you only end up utilizing 20% of those pre-drilled holes for remediation? Or do you instead use a round post and just simplify your life quite a bit more? When you're dealing with helicals, one nice thing, Dan touched on penetration rates with driven piles. So very similarly, you can do a correlation between the installation torques and the uplift capacity. You'll have to typically utilize, load testing to develop those correlations. That's something we do quite a bit for a lot of customers, both correlating drive times to capacity and also torque readings to capacity.
And I'm sure that those, you will find swings in those production rates depending on the pile. If it's a 6-meter pile versus a 1.5 meter, I don't think I've seen anything shorter than that. You're going to get different rates, just so that people listening understand.
And time of year. If you're installing in the dead of winter, it's harder, and you have shorter daylight hours. It's just
there's a lot of factors that go into that. Those production rates. Yeah, to your point, the time of year, maybe yeah.
Frozen
This,
fingers,
this-
frozen equipment.
this gets into a whole nother aspect of installing these systems, you know. Good to go in when you've got 1 or 2 inches of frost and a skid steer or an excavator like that will run on top of the ground without punching through and sinking in. But it's pretty easy to punch through 1 inch or 2 of frozen ground with a helical or any type of pile for that matter. But you don't want to be in that field in the fall when it's wet. You're not putting one pile in. Yeah.
A driven pile will penetrate frost, the deepest frost, 6-7 feet. It'll go like a hot knife through butter. A helical pile in winter, you have to pre-drill. So
Yeah.
there's an extra cost. You have to pre-drill, but you also
Just
have
to
to
get that.
backfill that frozen material. So it's tricky. Helical piles, like I say, they kind of go in a little clumsy. So you get that little gap around the pile. And if water can penetrate that gap and fill up and then it freezes, that will artificially grab your pile and pop it even more. Where a driven post will never have that little gap. So
Right.
with a helical, it's important to go around afterward and fill in that gap with the existing material.
Yeah. Especially depending on the time of the year, you'll have that effect.
Yeah.
Will be worse during certain times of the year, certain soil conditions versus others. And it's just, again, it's critical that you have the experience to know when you need to worry about it and when you don't need to worry about it. And yeah, that's just a lot of experience that goes into making those calls and making sure that you manage that construction schedule. And to your point, the quality of the install and what you're left with when the pile guys leave the site and you're a year, 2, 5 years into operation.
Always a blue sunny sky day. We're finding pretty quickly, like working in Prince Edward Island, the rain out there, the weather, it's every other day, right? Where southern Alberta, there's no rain at all. Like it's just sunny sky. You'll be lucky to get a drop. Although I think it is raining today. So,
and again, that impacts your production at the end of the day.
Really good.
So not all sites, not all piles, none of it is created equal, so to speak, I guess is my point.
Yeah, that all makes sense. We'll move on to the next. Okay, so next on our foundation list is ground screws. So ground screws can be utilized. They're pretty universal. Unlike the next foundation we're going to talk about, which are also universal, they don't require concrete. They can be installed into very bouldery, cobbly geology, similar to the bottom right photo there. They can also be drilled into shallow sedimentary bedrock. Of course, that'll require pre-drilling. If you're going into something with very large obstructions, it will also require pre-drilling. However, like we said, they're very universal. One of the challenges of them is, of course, the size. In a lot of cases, they can go up to, well, you theoretically could go as high as you wanted, but they're typically, from what I understand, the economics of them kind of cap out about 3.5 inches. And when you're dealing with some of the large wind loads and other bending moments that you got to resist from a racking system, that may mean that instead of having 1 post, you got to go to 2 posts. And anytime you're doubling your amount of foundations, you're typically doubling your potential for ground disturbance risk. And there's a lot more components that need to be aligned. And maybe Vishal can probably talk this a little bit with respect to it's all fine and dandy, and both Dan and Greg have alluded to it throughout the conversation. This is step 1, but if step 1 doesn't go smoothly, you're going to have a cascading effect down the line where if, for example, in every row you missed a pile because there was an obstruction that wasn't considered in the design, and you don't have complete rows, all of a sudden you can't do your complete racking, you can't do your complete wiring, and costs arise when you got to go back on a project and start backfilling, sending crews from the southeast corner back to the northwest corner because they didn't adequately consider the geological conditions. And so when the foundations land in place, you need a racking system that can tolerate potential movements. Dan spoke to it quite a bit. it's always nice when we got the driven pile and you got the laser beam rows,
Yeah.
but when you're dealing with helicals and ground screws, foundations tend to wobble. And, that's where, a racking system that can tolerate, those differential movements and the adjustments needed to adequately erect a site, gets you to a successful construction project.
So I do appreciate the plug or the setup, because we did design our site at the beginning. Most of the sites we were doing were helical, so we did account for a lot of adjustment in our rack to accommodate. And Dan has been a good beneficiary of some of that
I've seen it.
adjustability
Yeah, I've seen it.
on site. So, when there is a pile that's off, you don't necessarily have to pull it out of the ground and fix it, as long as you know that the racking system can compensate for that, all the way through. So we have made a lot of effort to make it a very constructible product. Just getting back to ground screws specifically, we're seeing that's a lot more. We're doing a lot of projects in Maine, Massachusetts, even in Ontario now, where we're seeing ground screws are a great solution. They are, fairly economical from a supply standpoint, but again, to Arash's point, you're putting in 2 piles instead of one. So, you have to appreciate that there is a little bit more risk there. We can go pretty wide on the diameter, although, you do get, if you start going with like a 5-inch or a 5.5-inch ground screw, it's equivalent to a price of a 5.5-inch helical. So you're not necessarily saving on price there, but it still might be the right solution depending on the geology for sure. And generally, when you're pre-drilling and putting these in, we find that it is, it is a good solution, although, the pre-drilling definitely adds costs.
Way to avoid concrete as well, right? If
Yeah.
you're in shallow rock conditions or that only ground unconsolidated formations that keep collapsing on themselves, that's where a ground screw comes in. So again, there's no one silver bullet. So ground screws do have their place. Soft clays, they may pull right out of the ground. There's not a lot of flight there, where that might be a helical kind of solution. But this is a way to avoid concrete. So if you're installing in the winter, the last thing you want to do is have concrete trucks running around at -30. That's not fun for anyone. So,
Or if you're too far from a plant and you're timing out on your loads, you don't get 8 cubic meters off a truck in 15 minutes if you're that tight. It's just
a lot of work you're doing is on islands and Caribbean islands where there may not even be a concrete plant there, right? So, a ground screw is a fantastic solution for that, to give the friction and the bite without needing a concrete base, like a concrete matrix around it. So that bottom left picture there is actually a helical or a ground screw failure. That's where we were twisting into hard sandstone, and we achieved 9,000 foot-pounds of torque, and that's where a 3-inch ground screw started to twist on itself. So that's a situation where we said, okay, pre-drilling, that removes quite a bit of that resistance. Now we can get the pile down to depth with like a 7,500 to 8,000 foot-pound torque rating, right? So yeah, that's where pre-drilling, I put that picture in there intentionally because yes, you can have pile failure if your torque gets too high, but pre-drilling is a good way to minimize that. And to pre-drill, you just run like a 3.5-inch or 3-inch outer diameter downhole hammer. So it's a rotary percussive method, and it'll go through anything: boulders, cobbles, bedrock, you name it, even soil, sand, and clay. I know you don't like calling it dirt.
Yeah.
Right. Your last one was it's soil, not dirt. So yeah. Like a downhole hammer is a fantastic way to make that pre-drilling hole, and then you just twist in your ground screw afterwards. And again, you record torque similar to the helical pile.
Well, one thing I want to pick up on what you said, Dan, and I hear this, I've learned this from Arash more than anything, is that failure is great during, it's not great, but it's not a bad thing when you're testing. Like, you want to know what fails. So when you go, you rather fail on, 5 ground screws during testing than roll in there with 50,000 screws and then start like snapping piles, right?
No
So
such thing as bad data.
yeah.
Exactly, and that's just it. I mean, the whole main objective is to fail during pre-production. As we go through the foundation design process. You start with a geotechnical investigation, understanding what your subsurface conditions are, and whether that's test pits or boreholes. Then you move into pre-production testing program, where you are testing the different foundations that may be conducive to the proposed geology. And then finally, you go into production. But once you go into production, you've hopefully worked out all the kinks. You figured out, your foundation. Typically on most sites, probably about 80 to 90% of the site can be, utilized with one foundation type. Maybe you're using a slightly different helical size or helical blade. Maybe you're using a slightly different embedment depth or thread depth for ground screws. But there's minor adjustments. But then in that last 10, 20% is where you really lose the cost or lose the momentum of the project. And if you don't have that properly accounted for and quantified up front, that's where a contractor, that's a contractor's dream. A contractor told me a couple of weeks ago, their job is to find the holes in the design. And a good contractor will find those holes in the design, and they will. No, it wasn't Dan, actually. It was outside of solar, but they will find the holes in the design, and they will change order the project. And that's unfortunately a lot of cases. If you've got a cheap install price, that's something you got to be thinking about. Is what is the repercussions when this goes wrong? How do we fix this? What is the associated remediation costs? Because the base cost looks great, but once you add I think Vishal said double, and Greg said, if you're lucky, if you triple, quadruple the foundation costs, all of a sudden, somebody like Greg is pretty frustrated because his really good site isn't generating the return on investment that he needs.
I think an important point is that your company that you're hiring to do the testing, and here's where I'll flip it back to compliment to you, is that they understand what the end product is. So whereas PRI Engineering, highly focuses on solar, number one, they know the different types of foundation they can use, but number two, they understand what's going to happen during install in terms of, this is not like a building where you're going to put 6 foundations. This is a farm where you're going to put tens of thousands of foundations potentially. So you need to figure out the constructability as well as the design when you're doing the testing. I think that's a lot of value you bring to these projects. And then, secondly, how that interacts with the rack as they're going to, build. Now you've got the foundation in the ground, great. How is it going to interact with the rack as they got to put the rack up? That's something by, working with the PRI or a determination, that understands kind of both sides of the coin, for lack of a better description.
We've got it pretty dialed in. We've tested hundreds of projects across Canada, and all of them have gone flawless, just from pre-project planning, being ready for the what ifs, having that geotechnical knowledge from my side, from your side. I don't know if everyone's known, Arash and I have worked together for 15 years, building bridges, roads, schools, hospitals, you name it, doing site investigation work. So really complicated stuff. Now solar, it's just as complicated, and now we're dealing with a huge landmass. So in a cold climate, so that's really tricky, and clear across Canada, coast to coast, every province, every territory. So it's really important to have that diverse team that really understands the challenges and constructability. So
because we've seen other geotech reports that you can tell they don't have appreciation for solar and the repeatability of what they're about to embark on, and the foundation designs don't necessarily make sense for the end application, just because they don't have experience building a manufacturing plant in a field type of mentality, right?
Yeah, we're trying. That's exactly what it is. We're trying to achieve manufacturing-like efficiencies in an environment where you don't have a roof over your head, and Mother Nature can do whatever she so chooses to do with you or to you, and that's really an added challenge that solar has over a hospital, a school, where you've got a very sort of narrow deep foundation versus a broad, a very wide, shallow foundation, which introduces what I just described, Mother Nature, more so than in any other type of construction project in, you know, when doing a simple comparison.
Yeah, no, absolutely, guys. And I do apologize. We got to start wrapping her up. So just quickly,
Did we even get through all the pile types?
we're just going to quickly talk on micropiles. I mean, we've kind of indirectly talked about micropiles. You know, Greg, Dan, and Vishal all alluded to the expensive costs related to concrete. So we won't need to worry about going into that.
Yeah.
You know, one of the bigger challenges with micropiles in, I'm gonna look at Southern Ontario in particular. You know, many people know that Ontario was the kind of original home to solar in Canada. And a lot of people have heard a lot of the horror stories about the failures, and a lot of them were associated with micropiles. And one of the big misconceptions there was that more concrete is better. However, more concrete in the wrong region of the foundation is not better. And in a lot of cases, what was happening was you were getting collapsing soils in the frost zone, and they were filling the micropiles right to surface. And, you know, essentially frost uplift is the ground freezes, the water in the pores of the soil freezes and expands and puts an freeze pressure on the pile. And so that's really dependent on surface area. So if you increase that surface area, then you've got more frost uplift. So in a lot of cases, these foundations were being installed not as per the design. And, you know, the last point on the slide there, completing QA/QC is extremely important. That's, you know, that's one of the key things. I can't describe how important QA/QC is through any of your foundation types, but in a situation like this, unfortunately, you know, we saw a lot of failures caused because of people placing grout and concrete.
Presence of groundwater too.
Presence of groundwater, yeah, absolutely, yeah. Collapsing soils.
Water or tremmy or concrete.
Tremmy, yeah. And we're talking real specialized construction methods all of a sudden.
In the dead of winter.
In the dead of winter,
we did
yeah.
one site is 26,000 bedrock micropiles. Like that's a lot of rock drilling. And yeah, when you hit water, it just adds a whole nother ball game. The difference between a 10-inch hole and a 12-inch hole is your penetration rates slow down. You're using quite a bit more concrete, and then but a larger hole does allow you some room, with some wiggle room to get your pile plunged into the perfect location. So it does help with your pile accuracy, but with a tight hole, you're using less materials, but it can be a lot more difficult to get that pile where it needs to be.
Yeah, no, absolutely. And then, so, you know, staying on the theme of concrete, ballasted foundations, these are probably considered the most expensive, most typically used in landfills. So if you've got a capped landfill, it's pretty common that, you know, they would use a concrete ballast solution. It can be precast or cast in place. You know, areas where you cannot penetrate the underground, like a landfill, or on sites where you had uncontrolled fill activities. You know, the ground pressure that's placed on the ground from these structures is very, very minimal, very low load. So you're able to kind of control the settlement a little bit with this type of foundation, and you don't enter into the ground risks that's associated with going below grade. However, you know, the initial cost is probably double, but it's a little bit more guaranteed. So that's where, you know, you don't see a lot of these foundations, with the exception of landfill sites.
Carports too.
Or carports, yeah, exactly, where you have less foundation elements. So we've touched on the remediation a little bit. You know, we talked about the last 10%. You know, we've talked about frost sleeves. So essentially, what frost sleeves do, I've talked a little bit about ad freeze. It reduces that ad freeze pressure. So you know, think of it as an interface between the pile and the ground that will overall reduce the friction between the ground and the pile. Insulation can also be utilized. That's very, very expensive. You know, just think about rigid foam insulation that you would put on the outside of your foundation wall, and you would basically create like a dance floor around the pile with that material. Then, you know, one last remediation is utilizing a different foundation type. And, you know, maybe before I jump into that question, I'm going to go to one of the questions that was asked during the conversation. So it said here, when recommending combination foundations, mixed driven piles and helical piles, Do you prefer it split according to solar panel sections, more broad, or can we determine based on geological conditions more closely? So, absolutely, we want to look at the geological conditions. In a lot of cases, there's going to be what I would call a transition zone between one major geological deposition and another major geological deposition, in which, maybe, we had to draw a line in the array so that they could make a procurement. But we all know that line that, separates zone A and B is a little bit gray. And so in those cases, maybe we proposed a driven pile up into the line, but we find that the helical is required a little bit further south from that line. So, utilizing different foundation types is often the way to go. So if you've got a different mix, having the ability to kind of bounce your foundation types around, and sometimes it's hard to digest maybe an added cost of going out and buying an additional foundation element. However, overall, you'll probably find that the cost is going to be less at the end of the construction.
During production, where if we're working down a row and we start seeing low torques, we'll stop after 2 piles. We'll go to the opposite end of the row and work towards it. And then as soon as we find that soft zone again, that's where we'll stop. And then we can infill that area with a larger helix or whatever it may be. So we're delineating during production as well. And that's, I treat every pile like a data point. Like you mentioned, like manufacturing, like auto manufacturing. So we have a total quality management with upper control limits and lower control limits. We're trying to narrow that right down to the middle so that we have the least amount of waste. So I treat it as a manufacturing line with a total quality management, Six Sigma type of approach to it, which is really hard to find in drilling. Most drillers just stick a pile in the ground, no problem. But like you take a different approach to it for sure.
Awesome. So there's one last question before we wrap it up, or maybe take on one more question after that. And it says here, have you seen any limitations of compatibility between common trackers and ground screws or helical piles? And, I'm going to probably just punt that right over to Vishal real quickly. But, the key is that you're selecting a racking supplier that can accommodate different foundation types, because you never want to pigeonhole yourself to one foundation type.
Yeah, exactly. And we didn't plant this question, but in hindsight, I might have. So we do have our tracker at Polar Racking here, which is the Axis Select tracker. It can accommodate ground screws, helical piles, and a regular driven like I-beam type solution. So, just fact being a Canadian company and working with the geology up here and supplying a lot of projects in the Northeast, we recognize very quickly that we need to accommodate these different types of foundations, because your typical tracker company is kind of looking for those sweet 700 megawatt, 1 gigawatt sites where the ground is pretty flat and homogeneous, and there's not a lot of frost, so you won't necessarily need a screw or helical pile. But most of our projects, we're doing lots of projects now, like community solar projects in New York, 7 megawatts at a time. Like we're doing a few dozen of those right now, but ultimately there's 7 megawatts at a time, and we're using driven piles and ground screws on those sites depending on the site. And so yes, we can accommodate varying topography as well as varying ground conditions with again a multitude of foundation solutions here. So
so it's called ground mount solar, and the most challenging part about it is the ground. It's a civil project. Although the end use is electrical, a ground mount solar project is all about civil. That can make or break the project is what's under the ground. So proper pre-site investigation is critical. Proper installation practices is critical. It's going to make it. It's just like building a house. If your foundation is off, your racking installers are off, your panel installers are off, your project is off. So our goal is to get the project started on the right foot, to match the foundation to the geology. Again, all these are good viable solutions, and it's critical to have like every tool in your box available. I want to thank everyone for coming out, and I also want to thank Janet and Kim from OYA for putting this all together, because they did a great job when they worked through my slides with me and made it perfect. This is fantastic. Thanks, guys.
Yeah, that's much appreciated, everybody. We did have one last question come in, and it was, have you designed foundations for a reclaimed mine site? So Carl, I have actually looked, currently working on a reclaimed mine site in Alberta. If you've got some questions about that, maybe you can reach out to me separately, or I can reach out to you and we can see if there's some way to help you out if you've got a project for that's got those conditions. Unless there's anything else, thanks again to all the guests, Greg, Vishal, Dan. And as Dan mentioned, the behind the scene team, we would be nowhere without them. So much appreciated. And of course, thank you to all the viewers for joining us this afternoon. And feel free to reach out to any of us if you've got any further questions. Thank you.